Hello friends, in this video we are going to study about the pressure measurement device known as Pirani gauges. Here we will study the basic principle of working of Pirani gauges, their construction, applications along with the advantages and the limitations of Pirani gauges. So let us start with our topic. Pirani gauge, it is a type of thermal conductivity gauge which is based on the principle of thermal conductivity and is used for the measurement of low pressures like for the vacuum pressure measurement. So Pirani gauges, they are based on the principle of thermal conductivity. So they are a type of thermal conductivity gauge and they are used to measure the low pressures like the vacuum and the pressures which are in the range from 0.5 torr to 10 raised to the power minus 4 torr. Torr is the unit of the pressures. Now, the Pirani gauge, it was invented in 1906 by the scientist Marcello Pirani. So, this instrument is named after the scientist who invented it, that is Marcello Pirani. So, it is known as the Pirani gauge. Now, as I have said that the Pirani gauges, they are a type of thermal conductivity gauge which are based on the principle of thermal conductivity. So, let us see the basic principle of working of the Pirani gauges. So the basic principle of Pirani gauge is that we are having a conducting wire. We know that when a conducting wire is heated, then electric current flows through it. Why? Because when we are heating the conducting wire, the flow of electrons is increasing and current is what? It is the flow of electrons. So due to the heating up of the conducting wire, the electrons, they are excited and they start flowing in the wire. So due to the flow of electrons, the electric current start flowing through that conducting wire when it is heated. Now the rate at which the heat is dissipated from this wire, it depends on the conductivity of the surrounding medium. Okay, so when we are heating the conducting wire, it starts flowing the electric current. Okay, so we are continuously heating the conducting wire, so the rate at which the wire is dissipating the heat, that rate of dissipation depends on the conductivity of the surrounding medium. Now, conductivity that also depends upon the density of the surrounding media, that how dense the medium is. If it is more dense, then conductivity will be more, because the particles they are, can easily dissipate in the environment. Okay, and if the density of the surrounding media is less, then the conductivity is also less. Now, the conductivity, it depends upon the density of the surrounding media. Suppose that if the density of the surrounding media is less, then conductivity is less. Density means that pressure of the surrounding medium is less. So we can say that conductivity, indirectly it depends upon the pressure of the surrounding medium. So by measuring the conductivity, we can measure the pressure. So that is used in the Pirani gauges, that we are changing the conductivity of the wire, and by the change in the conductivity, we are measuring the pressure in the pressure which is surrounding the wire. So when the density of the medium is low, conductivity is low, and that is going to make the wire become hot for a given current flow, and vice versa also. So here we have seen that the conductivity of the wire is dependent upon the pressure, or we can say the density. If density is low, pressure is low, or we can say the conductivity is low. Okay. So conductivity is what? The flow of the electrons will be low. Okay, or we can say the flow of the current will be low, and the resistance will be high. So we can say that all these parameters, they are correlated with each other: the conductivity, the density, pressure, current, and the resistance. So we are going to use the relationship of these parameters with each other for the working of the Pirani gauges. Now let us see the construction of the Pirani gauge. So in the basic principle, we have studied that we were having a conducting wire, and the conductivity of that wire is changing. Okay. So in the construction, the Pirani gauges, they consist of a metal filament or the conducting wire. This metal filament is made up of, usually platinum is used as the metal. So this filament is suspended in a tube, means this filament is kept in a tube which is connected to the system whose vacuum or pressure we want to measure. So here in the Pirani gauge, we will be having a tube in which the metal filament, the platinum filament will be there, and this tube is connected with the system whose pressure we want to measure. So that pressure will be applied on the metal filament, and due to the changes in the pressure, the density of the medium which is surrounding the metal filament in the tube, that is also going to change. So the connection of that metal filament tube with the system whose pressure we want to measure, that connection is usually made either by a ground glass joint or a flanged metal connector which is sealed with an O-ring. So this is the description of how the system whose pressure we want to measure, that is connected with the metal filament. Now this metal filament, it is connected to an electrical circuit from which after calibration a pressure reading may be taken. So this filament is connected with the system also and with an electrical circuit, and with the output of that electrical circuit is going to give us the readings of the pressure which is applied on the filament. Okay, so input is applied on the metal filament which is coming from the system, and the output is coming out from the electrical circuit which is used to measure the pressure, which is going to give us the readings of the pressure. Now let us see the diagram, the circuit diagram of the Pirani gauge. So this is the diagram for the Pirani gauges. Here you can see that we are having the Wheatstone bridges there. Okay, and in the Wheatstone bridge we know that we are having four arms of the resistances. So this is the diagram of the Pirani gauges. You can see here that we have told that the Pirani gauge, it consists of a metal filament which is usually the platinum wire. Okay, so here you can see we are having the filament which is the platinum, and to this filament we are going to apply the pressure which we want to measure. So here we are having the applied unknown vacuum or the unknown pressure we are going to apply. Now tube this filament which is contained in the tube, that is the measuring cell, or we can say the chamber of the Pirani gauge. Okay, so this chamber is connected to an electrical circuit. Here the electric circuit is the Wheatstone bridge. We know that the Wheatstone bridge consists of four arms, and in the four arms we have the four resistances, and Wheatstone bridge is usually used to measure the unknown resistance. So in this arm we connect the unknown resistance, and in the other three arms we have the known resistances. So we say that in a Wheatstone bridge, suppose that if this is P, this is Q, this is R, and this is S. So these are the values of the resistances. So Wheatstone bridge is balanced when P upon Q is equals to R upon S. Okay, means the ratio of these arms is equal. Okay, so that same principle is being used here for the measurement of the pressure, because we have said here that when the pressure is being applied here on this filament, its conductivity is going to change, and conductivity means that the flow of the current is changing. Flow of current is more, it means that resistance is less, and if flow of current is less, it means resistance is more. So we can say that indirectly the conductivity is changing the resistance also. So here this resistance of this filament or this portion will be changed according to the pressure which is applied here. Okay, because pressure is changing the conductivity. So here we are having the compensating cell, and these resistances are already known to us. So we are measuring here the pressure by measuring the change in the resistance. Okay, so this is a type of transducer also, because it is converting an physical quantity, a non-electrical quantity, into an electrical quantity. Okay, we are measuring the pressure by measuring the change in the resistance. So this is a type of transducer also, which is used for the measurement of pressure. So here this was the diagram for the Pirani gauges. Now in the diagram we have saw that the main parts of the Pirani gauge are the Pirani gauge chamber. So the main parts of this arrangement or this arrangement for the measurement of pressure are: first is the Pirani gauge chamber, which includes a platinum filament. Second, we are having a compensating cell. This compensating cell is used to minimize the variations which are caused due to the ambient temperature changes. So for the compensation of this arrangement, the compensating cell is used. Then we are having the So both these Pirani gauge chamber and the compensating cell, they are connected or they are housed in a Wheatstone bridge circuit. So the main parts are the Pirani gauge chamber, the compensating cell, and the Wheatstone bridge. Now let us see that how this Pirani gauge is used for the measurement of pressure, how it measures the pressure by measuring the change in the resistance. First of all, a constant current is passed through the filament which is present in the Pirani gauge chamber. Now, when the constant current is passed through the filament, it is going to get heated up. Okay, so because we are having the conducting wire, and we have said that when the conducting wire, when current is passed through it, it starts heating up. Okay, and due to the heating up of the filament, it assumes a resistance. We get that it is having a value of the resistance in it, and this value of resistance is measured by the Wheatstone bridge. So at the first stage, the filament is connected, and we are passing a constant current through this filament. So this filament will act as a resistance, and this resistance is measured with the help of the Wheatstone bridge by using this formula P upon Q is equals to R by S. Because we know the value of all the other three resistances, this is the unknown resistance, so we can measure its value. Now after that, now the pressure which we want to measure, that is applied to the Pirani gauge chamber. First, we have measured the resistance by using the Wheatstone bridge. After that, we have applied pressure on this filament which is present in the Pirani gauge chamber. Now, due to the pressure which is applied, the density of the Pirani gauge chamber or density of the surrounding medium, that is going to change, because earlier in the principle we have saw that the conductivity changes, means conductivity, it depends upon the density of the surrounding media, and density means the pressure. So what we are doing, we want to change the conductivity of this filament. So for the change in conductivity, we are changing the density of the surrounding media by applying the pressure on it. So when we apply the pressure which we want to measure, due to that pressure, the density of the surrounding medium is going to change, and due to the change in the density, the conductivity is going to change. The conductivity is changing means the flow of current is changing. It means that the resistance is also changing, because when conductivity is decreasing, the flow of current is decreasing, resistance is increasing. Okay, so there will be a change in resistance, and that change in resistance will be again measured by the Wheatstone bridge. So now we have applied the pressure on the filament. So here you have seen that due to the applied pressure, the density of the surrounding of the filament changes. So due to pressure, density is changing, and due to change in density, the conductivity is changing. And due to change in conductivity, the temperature of the filament is going to change. And due to the change in the temperature, the resistance is also going to change. So you have seen that how the pressure which we are applying, which we want to measure, that has affected the resistance of the filament. And this change in the resistance is going to be measured by the Wheatstone bridge. So we can say that the change in resistance of Pirani gauge filament is a measure of the applied pressure. Okay, so if we properly calibrate this instrument, then by measuring the change in the resistance, we can measure the pressure applied on the filament. So in this way, the Pirani gauge, it is used for the measurement of pressure by measuring the change in resistance through the Wheatstone bridge. Now if we describe this working of this Pirani gauge in the form of a flow chart, then we can say that what it is doing, change pressure applied, changes the density, change in density changes the conductivity, change in conductivity changes the temperature of the filament, and change in the temperature causes the change in the resistance. So this is how the pressure and the resistance, they are related with each other. Okay. So this was about the working of the Pirani gauges. Now let's come to the applications. As I have told earlier that the Pirani gauges, they are used for the measurement of the low pressures like the vacuum, and also the pressure which are in the range from 0.5 torr to 10 raised to the power minus 4 torr. So we can say that they are used for the measurement of low vacuum and ultra high vacuum pressures. So generally the vacuum pressures are being measured by the Pirani gauges, which are in the range from 0.5 to 10 raised to the power minus 4 torr. Now comes the advantages. Advantages of Pirani gauge are that they are inexpensive. They give accurate results. Their response is good to the variations or changes in the pressure. Means they are, if any change in the pressure is being done, they are going to quickly respond towards that pressure variations. So also the relation between the resistance and pressure is linear. You have seen that the change in resistance is directly related with the change in the pressure. Also the readings, they can be taken from any distance. Okay, there is no need to take the readings from a close area. At a distance also we can take the readings from the Pirani gauge. So these are the advantages of the Pirani gauges. Let's also see some of the limitations of the Pirani gauges. One of the limitation of Pirani gauge is that the thermal conductivity and the rate of heat of dissipation of the conducting filament, that also changes with the changes in the pressure. So frequently we have to do the calibrations of the Pirani gauges so that it gives us accurate results for every time the measurement is being done on it. Also, when calibration of the Pirani gauges is being done, then different gases should be used for the calibration. Also, this Pirani gauge, for the operation of Pirani gauge, the electric power is a must requirement. Okay, because for the operation of the Wheatstone bridge, we require the electric power. So it is an instrument which requires the consumption of power. Okay, so that is also a disadvantage or limitation of the Pirani gauge. So in this video, we studied about the Pirani gauges which are used for the measurement of pressure by measuring the change in the resistance, and which are based on the principle of the thermal conductivity, that the thermal conductivity of the medium changes when the pressure is going to change. So I hope that this topic is now clear to you. Thank you.